In this lecture, we're going to zoom in and look at how template instances work in C++. And we will still be using the box container class template we did in the last lecture. And I want you to focus on two facts. One is that the template instance is going to be created for a given type only once. So for example, if we create one box container for int, and we create another one, and we create another one, all these box container objects will be using the same template instance behind the scene. So every time you create another box container for int, you want to be creating another template instance. The only thing that will be factored in is the methods that you are using in your object that weren't being used in objects that you had before. And this brings us to another point. Only the methods that are used are instantiated. So your template instance is only going to have the methods that you are using on your objects. To really drive this home, let's head over to CPP Insights and look at this a little more. Okay, here we are at CPP Insights, and this tool was created by this guy here, Andreas Fertig, if I am pronouncing the name right. You can go and check him out and support him if you really find this tool useful. I find it useful and it is really cool. So here we have our class template exactly like we had in the last lecture, and we're going to try and create a bunch of objects and see what kind of template instances we have to the right. So here we can create a template instance for point, for example. If we just create a point object like we do here and not call the add function here or method, let's see what happens. This is going to put in only the methods that are necessary to create a box container of point object. Let's try and run this through CPP Insights and see the instantiations we have on the right. The world is good, so we can look to the right here and let's go down and see that we have a first template instance. This is right here and it is instantiated from line 247 in our code, and it is right here. So we're going to see that we have a box container of point. This is our instance. And if we go in, we're going to see that we have the body n for the constructor because we need to be able to create this object. We have a destructor with a body, but if you go down, you're going to see that all the other methods really don't have a definition. It is just a declaration. And this is what I meant by saying only the methods that are used by objects are put in. In this case, we are only creating an object as you see on line 247 here. And this object will need to be killed if we go out of scope for the main function here. So we need a constructor for this to work, and we need a destructor to destroy our object. That's why we only have in the implementations for the constructor and the destructor that we are going to see if we go down here. You can see this here, but all the other methods are just the declarations. We don't have implementations then because they are not used by any object. Now let's go in and create another box container for point. We can create that. The first one is going to be point box1, and we can create a box container of point again, and we're going to call this point box2. If we don't do anything else and just create the object and run again, we're going to have the same thing we had before, because this will just need to create a box container object and destroy it. So this is going to put in the definitions for the constructor. That's what we see here, and the destructor. And you see that we only have one instance for point. We don't have multiple instances because we happen to be creating two objects here. But if we go in the second object here and create a bunch of points, we can do something like this. So point P1, and we're going to put in 10 and 10, and we can create point P2, and we're going to make this a 20 and a 20. We can do something like this, and then add these guys to point box 2 and add P1. We can do something like this and say point box 2 and add P2. Now, if we build, we will see that this method is used and we will need a definition for it. So the definition will be included in our template instance here. This is what I want you to see now. In the last run, we didn't have an implementation in for the add function. Remember, the add function also needs to use the expand functions. So the definition for add is going to need a definition for expand, and we're going to put this in. And now if we run this through CPP Insights, we're going to see that the definitions for add and expand are going to be put in because they are used in our object here to add stuff to our paintbox2, to add stuff to our paintbox2 object. Let's go down and look at our instantiations. We have the same instance we had before. We have a constructor in the body. We have the body for our destructor. But if we go down, we're going to see now that we have a definition for the add method. And if we go down, we're going to see that we have a definition for the expand method. This is really what I meant. And again, all these guys are part of the same template instance because this is the same background code that will be used to power these objects we have here. I hope this makes sense. And this is the message I had to convey in this lecture. It doesn't matter how many objects you create for the same type, you are going to only have one template instance for them. And that template instance is going to contain the methods that are used throughout these objects here. For example, let's go to the top and see what we are using here. For example, what are we doing? Do we have a size method? Let's see if we have a size method. Let's go in our guy and we have a size method. So let's see if we can use this. If we go down in our template instance and look at the size method, so you see we only have a declaration n, but if we, for example, use that on our first object, let's do that. We're going to scroll down to the main function and say paintbox1 and say size. Now this is used in the first object here and it will be included, I mean the definition, in our template instantiation. Let's run this and we will see that this is no longer going to be just a definition. We will have a body n for our definition. Let's go down and see that and hunt the size method, and it is right here. You see that we have a definition because it is needed for the first object. We also have the add method because it is needed for the second object here. So all the methods that are used by all the objects are going to be included in your template instance. This is what I wanted you to see here. We are going to stop here in this lecture. In the next one, we're going to learn about non-type template parameters with class templates. Go ahead and finish up here and meet me there.